Hello, and here is an introduction to binary, decimal, and hexadecimal. That's base 16 numbers that you can use in any computer science class, including the 2 AP classes. So we'll go over this in class, but if you want a review, here's a good review. Binary, base 2, 1 bit of data has only 2 possible values, 0 or 1, true or false, on or off. Only 2 possible values, and everything else is made up of that. That is 1 bit. 1 byte is 8 bits. And because you have 2 choices for the first bit, 2 choices for the second, 2 for the third, 2 for the fourth, 2 for the fifth, 2 for the sixth, 2 for the seventh, and 2 for the eighth, there are 2 to the 8th or 256 different possible values that 1 byte can hold. So for instance, you would use 1 byte to represent a character in the ASCII format, and we'll see more ASCII as we go along. 2 bytes is 16 bits, so there are 2 to the 16th possible values, 65,536 possible values. Unicode uses 2 bytes to represent each character. Unicode is an international coding methodology that you can use to represent all sorts of international languages that don't fit nicely into the ABCDE format. It can use Asian languages, can use Arabic, can use Cyrillic. All of those need Unicode. And in fact, emojis are one Unicode language. So there we go. With 3 bytes, you have 2 to the 24th, which is just over 16 million different possible values. And in fact, so 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0. That is 24 bits. That's a particular 3-byte number. And colors are generally represented with 24-bit color on modern computers. There's 1 byte for red, 1 byte for green, 1 byte for blue. So this, for instance, would be a lot of red, quite a bit of green, and a little bit of blue if you were looking at that number. Just out of information, people's eyes can distinguish between 10 and 15 million colors. So with 16 million different possible values, that covers everything that humans need to see. If you put it together in 4 bytes, you get 32 bits. There are about 4 billion different possible values, and Java, C, and many other languages use 4 bytes for integer values. So if you need an integer that goes between about -2 billion to 2 billion, an integer will handle that for you. If you need a number that goes bigger than that, there are other options that we'll talk about at some other time. But for now, know that Java and C use 4 bytes to represent an integer. So as we move on here, need to think about place value. What does place value mean? And that will help you understand binary numbers. Read the number out loud. You said 753, I hope, which means 7 100s, 7 times 10 to the second, 5 10s, so that's 5 times 10 to the first, and 3 1s, which is 3 times 10 to the 0 power. So we're doing powers of 10 here. 10 squared, 10 to the first, and 10 to the 0. This number, 2048. Read it out loud. You said 2000s. You didn't say anything about hundreds, most likely. There are no hundreds. 0 times 10 squared, 4 times 10 to the first, and 8 times 10 to the 0. This is base 10, or decimal numbers, the same DEC prefix that you use when you talk about a decade, or a decimeter, or things like that, or a decibel. So there we go. If you're moving that into binary, base 2, you're using base 2 instead of base 10. So this is how many 1s, this is how many 2s, this is how many 2 squareds, or 4. 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, and 2 to the 7th is 128. So how many of each of those numbers? This one together has no 128s, no 64s, it has 132, it has no 16s, it has an 8, no 4s, no 2s, and 1. So it's 32 plus 8 plus 1, also known as 41. There you go, that's binary to decimal. So you would write it this way. By the way, in these classes, we're only going to deal with binary numbers up to 1 byte, so 8 bits. So just like we got here. 2 different ways to write this. Either you can use the word binary or decimal, usually abbreviated BIN or DEC, or base 2, base 10. It's all good. So decimal to binary is sort of the opposite. You say, how many 128s are there in that number? How many 64s are in what's left? How many 32s? So we'll start with 183. How many 128s? There's 1, and that leaves 55 remaining. How many 64s? No 64s. So there's still 55 remaining, but we can take a 32 out. That leaves 23. We can still take a 16 out. That leaves 7. Can't take an 8 out because we only have 7, but we could take a 4, a 2, and a 1. So that tells me that our number is 10110111. 10110111. Good. Lots of practice available online. Hexadecimal base 16 is also used to shorthand a bunch of pieces. A hexadecimal number is 4 bits, half a byte, sometimes called a nibble. And if you have a binary number that's 1 byte long, you can break it into 2 nibbles and convert each nibble. So here we go. Zeros is 0. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all normal. This would be the decimal number 10, but we're looking to do base 16, so we need a symbol. So you would go to A, B, C, D, E, F. And when you talk about colors, for instance, when you're looking at a color picker, you will see the letters A through F included as well. If you're doing binary to hexadecimal, very straightforward. Break it into 2 parts and look up each part. This is 2, this is D. There we go. If you want to look back at that, 0010 was 2, 1101 was D. There we go. If you're doing hexadecimal into binary, that's pretty straightforward. Go back the other way again. 3C, this would be 3 in decimal. This would be 3 in binary. This would be C in binary. There you go. So there's the number. This would be 4. This would be 5. Life is good. Hexadecimal to or from base 10. We could go a couple ways. We could go 3C in hexadecimal. It's 3 16s and 12 1s for a total of 60. 125 in decimal, or going the other way, 125 in decimal is how many 16s? It's 7. And that leaves 13 left over. So 7 and 13, 13 represented by the letter D. Or you could stop through binary because from earlier parts of this, you've already learned how to do binary. Enjoy. Have a good time with binary numbers, hexadecimal numbers, and we'll do more work. Come on, close. Close, close, close. Why is this not closing?